Time for part 2 of Matlab Tic-Tac-Toe. Change this so I can remember which version I'm in. Tic-Tac-Toe 2. This is all the same. One of the instructions in the assignment says we want this to have a game loop. A game loop is a concept in gaming that... There we go. That's where we want it. We want the game loop to be started after the initial setup. A game loop goes forever, meaning it ends when the game ends. And we want to go right down here, right before our function call, because this entire thing is going to be our game loop. So we put an end in there. I'm going to indent this code over. I like that method, because then I can keep track of what in the world belongs to what. So we still get the player's move. We get our input into the move variable, but this time around, we're going to break out of the game if the player has had all they can handle. So that's going to be an if statement. If the player enters a 0, we're going to display, "Thank you for playing tic-tac-toe," break, exits the while loop, and as there is nothing else in our program, we're at the end of the program. So that's the first piece. The next piece that we want to do is check to see if we have a valid move. We don't want the user or the computer, well, in this case, just the user, to be entering moves that are not valid, like putting their number on a spot that's already been taken. We're going to create an isValidMove function that will return a Boolean. This is either going to return true, in which case we update the board just like we have before, or it'll return false, which means invalid move, please try again. Continue skips the rest of the loop, goes right back up here and says enter again. And so we keep doing that until we get a valid move. Let's find the isValidMove function. It's right over here. I'm not going to type it in. That's boring to watch people type. Well, maybe it's not too boring, but I'm not in favor of typing things. All right. There it is isValidMove. So to set up a Boolean isValidMove, I just put valid. Either it's valid or it's not. Computers are zeros and ones. Either it isn't or it is, or ones and zeros. We're passing in the current move, which in this case is 3 or whatever it is. We're passing in the board. Well, just like we did before, we have to convert the move number to row and column indices. Well, this is exactly what we did before, so we could abstract this out into its own function. You can do that if you wish. For now, I'm just going to duplicate the code. So at the end, we end up with the row and column. So if this row and column is equal to 0, we return true. If the row and column is not equal to 0, we don't return true. In this case, we're testing one condition rather than testing for 1 and 2. When we return back, this will either return true or false, keeping us going. Now, the last thing to do here is create the computer's move. Well, that can be done, again, just like everything else can be done many, many, many different ways. I'm going to put that in here. There's the computer's turn. Let me paste in my function. All right. Scroll down a touch here. All right. So we're going to get the computer move. We're going to pass in the board. We're always passing in the board because the board is our state of the game, keeps track of our game state. When we're done, we're going to have a move. We want to find all of the board cells that have a value of 0. This returns a vector, which is going to have an index of 1, 2, 3, 4, 5, 6, or however many things are returned. We want to find the length of that vector, which is going to be 1 or 5 or whatever it is. Actually, the first time around, it's going to be 8. Because we've made one move, there's now 8 moves left. We're going to randomly pick an integer from that. Say we pick 4. That gets stored in the random index. We take this into our available moves and use it to pull out what's called a linear index, meaning our vector is linear, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 8 in this case. This is a function that will convert an index into a matrix, into the row and column of the matrix. So it takes the board, how big is the board, it takes this index, and it returns the row and column of whatever number we have. This next part is the reverse of what we did before. If the row is 1 and the column is 1, we have move 1. If the row is 1, if the column is 2, we have move 2. So we're reversing the conversion that we did before. We also have to use this. It has to be both. It has to be row equals 1 and column equals 1. If the row is 2 and the column is 1, the move is 4. When we're done converting that, the move will have a value that will be returned up to here where we have the call. The computer's turn. Well, we do get, oh dear, computer move, and the signature has to match, meaning what we pass to it has to be the same thing. We're going to be returning a computer move. So I think I'll just call it computer move. Oh, it says move down there, doesn't it? Let's just say move then. The variables do not have to match. They can match, they don't have to match. It's the value that gets returned, not the variable. Well, what do we do next? Well, before we've got our move, right? Probably the first thing we need to do is set our turn equal to 2. That's not necessary for this guy, but it is necessary for the next piece, which is, of course, we update the board. Oh, I had that wrong. There we go. So there we go, we update the board. We've got our move, and I don't know why I put computer move in there. I guess I don't have to. I could if I wished. There. This updates the board. Then, of course, we want to let the user know that, yep, the computer moved, and update the board so we can see what's going on. And I could use computer moves, computer move. Regardless of what I type in, let's try our game. So I'm going to put 1. So far, so good. Except I ended up with 2 1s here, so something's not quite right. Okay, now we're back in business. Yep. If I enter a 3, now what happens if I enter a 2? It's an invalid move. Until I enter a valid move, it's just going to keep, even if I entered the move, I can't overwrite it. But I can go to 4, and the computer automatically randomly picks another number. Well, randomization is like the dumbest AI ever, but it does give you the sense that you're playing with somebody else. So we display the welcome message to the player. We create a board with zeros. Then we display our board. We're in our while loop. Enter your move. If the player move is 0, we exit. Now we're at the player's turn. Is this a valid move or not? Well, let's go down to is the valid move just to review. Is the move valid? We've passed in the value of the move, value of the board. We need to convert the move into row and column indexes. So if the move is 1, it's 1 and 1. If the move is 2, it's 1 and 2. Okay. Then, once we've got it converted, we're going to check to see, is that row and column the same as 0? Is it empty? Is this true? If this is true, valid is true. If this is false, valid is false. That takes us back up to, here we are. Here, if this is true, we update the board. Well, we put in the player move, we put in the turn, we put in the board. Let's go down to update board. There it is. So we pass in the move, the turn, the board. If the move is 1, well, you've seen this before. Could be made into a separate function, as this note says. Guess I really don't need that note. I already know it can be converted into a... Well, no, we'll keep it in there. It's repeated. We see it again. We could abstract it into another function. That's a challenge for you. By the end, we have the row and column. We have the turn with the 1, and that marks up the board. And in this case, we aren't using this for the computer. We're only using it for the player. There. Now where are we? Okay, so we displayed the we displayed, updated the board. If it's invalid, we continue, start over again. Display the board just does a display board method function. Later on, we may get fancy with it. All right, so now we move on down. It's the computer's turn. We're going to get the computer move. We're going to find all the cells that have a 0 in it. And that's going to return a vector. So the first time around, that's going to be 1 through 8. How long is that vector? Well, it's 8. We pick a random integer and say it's a random index. Then out of those available moves, whatever it is, 1, 2, 3, 4, 5, 6, 7, 8, we then return that as a linear index. Vectors do linear indexes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So now we go to available moves. Whoops. Okay, here we are. So then we convert this index into whatever cell, row, column, cell it's supposed to be. Then we go through all this, which is the reverse of what we did before. Row, if row is 1 and column is 1, move is 1, on and on. That returns move. And the computer moves. The computer, we update the board, we display, computer moves, and then we display the board. Well, that completes Tic-Tac-Toe Step 2, or Part 2. Part 3 coming up.